Out on the open ocean, storms can strike without warning. Giant ships and oil platforms must stay anchored, no matter what the sea throws at them. What keeps them secure? Not just a heavy anchor, but the anchor chain. These chains are the unsung heroes, connecting vessels to the seabed with incredible strength. Without them, ships would drift, risking disaster for crew and environment alike. Imagine a cargo ship, a floating skyscraper facing the full force of a storm. The anchor chain absorbs all that stress day after day. Each link can weigh more than a person, and the chain itself stretches for hundreds of meters. Hidden beneath the waves, it's always working, allowing sailors to sleep and oil rigs to operate safely. The chain is only as strong as its weakest link, so every link must be perfect. Building these chains is a feat of engineering, combining old-school metalwork with modern tech. It starts with special steel and ends with brutal tests. The journey from raw metal to finished chain is a story of fire, force, and precision. It's a tough, essential job that keeps global commerce and safety afloat. Let's see how these giants are made. You can't make a world-class anchor chain from ordinary steel. It starts with high-strength, low-alloy steel, engineered for toughness and corrosion resistance. Elements like carbon, manganese, and silicon are added for hardness, strength, and purity. This special blend fights off saltwater corrosion, ensuring the chain lasts for years at sea. The steel arrives as massive ingots, which are cut into billets, thick, 1-meter bars. Each billet becomes a single chain link, giving you a sense of the scale involved. Consistency is crucial. Every billet is measured, weighed, and inspected for flaws. Even a tiny crack means rejection. No weak links allowed. Only flawless billets move forward, ensuring the chain's reliability. This strict quality control at the start is the foundation for everything that follows. The right steel, perfectly prepared, is the first step in building a chain that can survive the ocean's worst. Every link's journey begins with this uncompromising selection. The process is all about eliminating weakness before it even starts. Only the best steel makes the cut. That's how you build a chain that won't fail. Next, it's time to shape these billets into links. Now comes the heat. Steel billets are heated in a furnace to over 1200 degrees Celsius, glowing bright orange and ready to be shaped. At this temperature, the steel is soft enough to bend but still incredibly tough. Robotic arms or skilled operators move fast. The steel cools quickly. The billet is pressed into a U-shape by a massive hydraulic press. Each new U-shaped link is threaded through the last finished link, interlocking the chain. The open ends are brought together, ready for welding. Precision is key. Every link must align perfectly. Sparks fly, heat radiates, and the process is a dance of man and machine. Operators must work quickly and skillfully before the steel cools. This is where raw metal becomes the backbone of the anchor chain. Each link is shaped under intense pressure, one at a time. The transformation from billet to link is both art and science. It's a noisy, hot, and demanding job, but it's how the chain's strength is forged. With the new link in place, it's time to close the loop. Flash butt welding fuses the open ends using massive electric current and force. The ends are clamped, electricity heats them to near molten, and a hydraulic press slams them together. The result, a seamless, ultra-strong weld, often stronger than the original steel. Computers monitor every detail, temperature, current, pressure, to ensure perfection. Any flaw, and the link is scrapped. While still hot, a trimming machine removes excess metal, leaving a smooth finish. The process is fast, precise, and unforgiving. Only perfectly welded links remain. Each connection is as strong as possible, ready for the next challenge. This is where the chain's integrity is truly locked in. The chain grows, link by link, each one tested by fire and force. Now, the chain is ready for the next stage: heat treatment. Welding is just the start. Now the chain must be toughened. Heat treatment transforms the steel's internal structure for maximum strength and flexibility. The entire chain is reheated to around 1000 degrees Celsius, then rapidly quenched in oil or water. Quenching makes the steel hard, but also brittle. To restore toughness, the chain is tempered, reheated at a lower temperature, then cooled slowly. This two-step process balances hardness with flexibility, so the chain can absorb shocks without breaking. Every step is precisely controlled. Temperature and timing must be perfect. The result, a chain that resists wear, withstands storms, and won't snap under pressure. This is the science behind a chain that can survive the ocean's fury. It's a process of extremes, heat, cold, and careful calibration. The chain emerges ready for the ultimate test. Only after this treatment is it strong enough for the sea. The next step, proving its strength. Let's see how it's tested. Building a strong chain is one thing. Proving it is another. Every chain faces the proof load test. It's stretched by a hydraulic rig with forces far beyond normal use. Each link must withstand at least twice its rated working load, with no permanent stretch or deformation. Sensors track every movement. Any failure means rejection. Some links are tested to destruction, pulled until they break, to find the true breaking point. This destructive testing ensures the chain is even stronger than required. Ultrasonic inspection follows, using sound waves to detect hidden flaws inside the steel. Even the tiniest crack or impurity means the batch is scrapped. Only chains that pass every test, strength, flexibility, and internal integrity, move forward. The standards are unforgiving, but safety demands it. These tests guarantee the chain can handle the worst the ocean can deliver. It's a brutal process, but it's the only way to ensure reliability. Every chain that passes is ready for the next challenge, fighting off rust. Now, it's time for protection. Here's how the chain is armored for life at sea. Saltwater is relentless. Without protection, even the strongest steel would rust away. The finished chain is cleaned and dipped in molten zinc, a process called hot dip galvanizing. The zinc bonds to the steel, forming a tough sacrificial layer that corrodes first, protecting the chain. Every surface, nook, and cranny is coated for maximum defense. After galvanizing, the chain is painted with marine-grade enamel for extra protection. This paint resists salt, abrasion, and impacts, giving the chain its signature color. For extreme environments, advanced coatings like epoxy or composites are added. These layers shield the chain from cold, ice, and physical damage. This multi-layered armor lets the chain survive decades in the harshest conditions. Without it, the chain wouldn't last a single voyage. Protection is as important as strength. Now the chain faces its final inspection. Before shipping out, every chain faces a final, meticulous inspection. Inspectors walk the length of each section, examining every link for defects. They use hammers, gauges, and their trained eyes, listening for clear rings, checking for perfect dimensions. Even a millimeter's deviation can mean rejection. Each chain section gets a metal tag with its full history, factory, date, steel composition, test results. This traceability ensures accountability and safety. A master inspector or third-party surveyor gives the final sign-off. Only after this approval is the chain shipped out, ready for the sea. This last human check is the ultimate guarantee of quality. The process is rigorous, but there's no room for error. Every chain that passes is ready for a lifetime of service. Now, let's look at the future of chain making. Chain making is ancient, but today's process is high-tech. Robots and automation handle welding, lifting and measuring with unmatched precision. Laser scanners and artificial vision systems ensure every link is flawless. Automated manipulators make factories safer and more efficient. Ocean simulation tanks test chains in real-world conditions, saltwater, pressure, and violent waves. Only chains that survive these extreme tests earn the highest certification. Grade R5 chains anchor the world's largest oil platforms in the deepest waters. Innovation in robotics and materials keeps pushing the limits. As ships and platforms grow, so do the chains that hold them. The future is strong, smart, and safer than ever.